sessions back to back from this month and onwards. And you can also provide suggestions via our community channels, which information topics you are more interested on and which speakers we want to listen to more. Uh, so we will help at conducting those sessions effectively. So today with us is Syed Muhammad Hani, who is a generative AI engineer at Cogent Labs and is a very brilliant engineer in field of generative AI, who will be conducting our session today on Google Gemini in prompt engineering. So I am handing over the mic to Syed Muhammad Hani, who will be starting the session. Thank you. Over to you, Hani bhai.
Thank you for the introduction. Hello, everyone. I think we can get started. But you can share the screen.
Yeah, sure. Just a second. Is the screen visible?
Yep, it is. So, first of all, let's talk about why are we even talking about generative AI? Because when we talk about traditional AI, we always used to approach the problem whether it's a supervised learning problem or an unsupervised learning problem. And beyond that, we would then think about, okay, if you want to apply classification, if you want to apply clustering, if you want to apply CNNs, and we would have kind of a limited approach to what kind of things that we could uh, accomplish. The thing with generative AI is that we have a lot more scope. We have increased the scope for solving problems. And if we go over to the next slide, we can have a side by side comparison. So, first of all, when we used to talk about traditional AI, it is very task specific. So, let's say you have a model that recognizes faces of 30 people, it's not going to recognize the face of the 31st person. That's on the data it was trained on. When we're talking about generative AI, it's more towards creating new content and creating new images and text. Secondly, if we were to talk about on which kind of rules it uh, lays out, it's more traditional AI is more towards the rule-based learning and the rule-based applications, whereas when we're talking about generative AI, it's more about recognizing patterns, connecting the dots, and coming up with new things. That's also a point where we come across the problem of hallucination, that when it starts to connect the dots between things that are not even connected at all, it starts to make some sort of sense because they seem semantically similar to an LLM. It starts to connect the dots and creates a content that does not exist. It's, you could say it's false. It's fabricated. So that's basically it. We can go over to the next slide and get started with the prompt engineering. So, if you were to start prompt engineering, I'll type something in the chat for you guys. There's this website, I'm sure most of you must know about it. It's called deeplearning.ai. So, deeplearning.ai had introduced their prompt engineering course, and that's probably the best place where you can learn about, like, where you can get started about prompt engineering and what are the general practices you can follow for prompt engineering. Here what we're going to talk about is a little bit different to the courses that we already have available online. So the first thing is that when we're talking about prompt engineering, it has basically the power to solve 80 to 90% of the cases for generative AI. Just a good prompt, a single good prompt has the power to, like, convert some rubbish text into something very meaningful. And we don't even have to use fine tuning for that. We just have to come up with, like, experiment and come up with a great prompt. One key for doing so is to use simple keywords. Let's say I want to summarize a text. So what I'm going to do is I'm going to tell it in the system prompt that okay, your task is to summarize the content that I will provide you. Next sentence, if I'm going to say, like, my next sentence is going to be summarize this text, write it within 100 words, all of that. But there's an inconsistency. The inconsistency being that first in the system prompt, I explained it, you have to summarize a content. The next sentence, I'm talking about a text. So when I'm changing the keywords, I'm essentially varying from content, and then I'm talking about text. It's going to confuse things. It's going to, like, LLM is going to think that maybe these two are different things. That content and text are two different things. So what we want to do is keep the keyword simple, use a single keyword, and just use that, like only use that keyword throughout to maintain a semantic meaning throughout the entire prompt. So if we can go to the next slide, here's another important thing. You want to structure the prompt, and for structuring the prompt, you can easily find examples that the one way to doing so is using delimiters, and a second way of doing so is by using um, indentations, and then the third way would be to use line spaces. So you're going to essentially come up with a combination of all three of those. So if I were to, okay, I cannot type. Okay, so if I were to come up with a combination of all three of those, I would probably do something like, here is the task, and give it a task in here. I'm typing it out in the comments for you guys. Um, and then I would use something like this. So if I want to, like, use a combination of delimiters, line spaces, and indentation, I would do something like this, where the task and the instructions would be something um, with an indented bullet points, and we can get on with the entire um completing the task. So, Ahmed, I think if there are any questions from the audience, we can take them. We can start taking them right now, and then we can move on towards the techniques.
Sure, Hanway. So, guys, if you have any questions, you can raise your hand and ask away your questions. I believe there are no questions so far, but if you have any questions at any point in the session, you can raise your hand and ask your questions.
Okay, I think we can move ahead with the next slide. So, here are a few techniques that you are going to find online for the most part of whenever you get started with prompt engineering. The important key to remember is that you don't have to remember which sort of technique I am going to apply to this prompt engineering task. It's more important to get an idea of what the intent behind these techniques is. So when we're talking about the zero shot prompting, basically saying, okay, I have a task, I want you to do this, and that's it. I'm not going to provide any examples to the LLM. I'm going to give it like a task and the instructions for that. But no examples. When we're talking about one shot prompting, it's usually for very simple kind of JSON structures where we just give it a single example of okay, this is how a JSON is going to look like. Take the input, convert that into a single JSON, and that's where you have the one shot prompting. Few shot prompting would be something where we provide multiple examples, and it's usually more towards the non-technical side where we end up using that, and it would have like more than one, but less than you could say 20 examples, because when we are talking about a lot of examples, then we have the many shot prompting, which is I believe not mentioned here. Another way of uh, structuring your prompt is the chain of thought, where you give it an entire chain of thought that okay, first you're going to do this part, then you're going to complete this instruction, then you're going to complete this instruction. Once you have completed all three of those, then combine all of that into a code. Similarly, for tree of thought prompting, it's something that is really um, helpful whenever we are summarizing a text. So for tree of thought prompting, what we are going to do is we are going to give it a number of chunks. Let's say 10 chunks. Each chunk is going to be a single thought, and once it summarizes one chunk, we are going to combine all of those results into the next chain of thought. So it's going to form something like a map reduce kind of a structure for tree of thought prompting. And if we can go to the next slide, we have something that is going to be like, I think it's going to be of interest of many of you. So talking about hallucinations is really important. Hallucinations are probably one of the first problems that we got regarding LLMs. That okay, it has started making up information, and it's not like hallucinations are not like a problem. It's more like it's actually overdoing tasks. LLMs are basically overdoing tasks instead of a bug. So, and it's not limited to a single model, it's not limited to a number of models, it's something that happens with each and every part. So, it's basically kind of a byproduct you get from LLMs that are able to join the dots, connect the dots. To resolve this, we have two ways in the industry. First one is that whenever we have any sort of a task we want the LLM to complete, we're going to provide we want the LLM to provide all of the information that it has created with references. So when we have the references, it will be easy to cross check. The second way is that the if the LLM does not have any information regarding the task, it's just going to apologize that okay, I am sorry, but I do not have enough information. This is something that started like it was a problem with many LLMs at start, with like just their chat interfaces, the chat interfaces of any LLM. At first when they were released, we used to get like wrong, like incorrect information. They would create information from their own, but now we have like a lot of uh, layers to the entire structure. That's why if you're going to ask who won the 2025 World Cup, it's going to say okay, I do not have that information, I'm sorry. When we're talking about prompt engineering, we're going to always opt for the second option, because the first option is something where we need to include a database or a vector database or an external tool or something else. We will have to incorporate some sort of a third party or an external source of information that is not directly connected to the LLM. We will have to provide information from that source to the LLM. So that's not something we're going to do if we want to accomplish the task just using prompt engineering. What we're going to do is written down below, and it's something very important. I think you guys should like at least give it a read. The first thing is that what we want is that the LLM does not generate anything from its own knowledge, and the instructions that we want to give to the LLM is going to be are going to be something like instruct to create content. So if we are talking about a summary, I'm going to say that you are not allowed to add any information from your own knowledge. Use the information only that I have provided you in the message above. It's going to sound something like that, but yeah, that's going to fix most of the cases for hallucinations for you for almost all the models. And that's basically how you can overcome the problem of hallucination. What you would be thinking is, okay, it's not creating false information, but it's not creating any information either. So isn't it a failure? But the thing is that if it does not have any information, it's better to not have false information. And it's better to not have any information instead of having false information. So yeah, we don't want any those sort of errors, especially when we're talking about businesses. When we're talking about business use cases, we don't want hallucination in any sort of way. Just because it looks great, that okay, it has generated something, that's not what we want to uh, go for. So if we go to the next slide, we have an example for something that can be resolved using prompt engineering. Okay, so take a minute to read this. I think you guys are familiar with this example. Okay, so this is a pretty common meme that was popular. It's probably still very popular that it you want to count the number of a character, the number of characters in a word, and the LLM messes up. So here we have an example from ChatGPT. I asked it. I wanted to try two things here. First of all, we wanted to count number of characters in a word, and secondly I gave it a wrong word intentionally, like a wrong misspelling intentionally, because what LLMs tend to do is when you mistype something or misspell something, they tend to correct that first and then move on to the next steps. Here, however, it was smart enough to identify that I wanted to talk about the word stranger with two R's, basically two R's after the T, so stranger with three R's basically. It was able to figure that out. Okay, so this is going to be my first step. But what about the next step? It kind of messed it up. It wasn't able to count the R's. And we even specified that, okay, I'm talking about the R character and I'm talking about the stranger word. Yeah, that is so. Um, if we talk about, if we go on to the next slide, then I corrected the word. I corrected the word to strawberry because that was the more popular term. So, how many R characters are in the word strawberry? That's something that it was unable to do as well. I have a comment from OS that it has three R characters. Yeah, that's actually cool if it is able to do that. But what we want is to have like 100% sure way that it is able to count the correct characters. So we are going to ignore the first part that okay, stranger was had a like a spelling error. we're going to move ahead with strawberry. We want to just make sure is it able to count the um, characters correctly if we tweak the prompt a little bit. So if you go to the next slide, okay, so I think we might want to zoom in here.
I'm unable to zoom in right now. Hani bhai, I am unable to zoom in right now.
Okay, I
Is
can share the screen actually. Okay, let me know if my screen is visible.
yes, it's visible. It's visible.
So if you're talking about fixing the prompt, there's one thing that I just changed. It was this single line below, which says, first of all, give it time to think. This is something that's covered in the course for um, from deep learning AI. Give it time to think. The second thing is break down character by character. And the third part that is also included is in that once you have broken down it into character by character, then you are allowed to reach a conclusion. And that's what it does. It does something uh, like a surefire way that it breaks down the word, and that's what we wanted it to do. We wanted it to break down the word, count the hours, and then give us a result. And let's go over to the word with the wrong spellings. So we have the word. So we have the word stranger with the incorrect spellings, and we give it the same instruction, the same prompt, the exact same thing, and it started working for the incorrect word as well. So the problem wasn't with the word being correct or incorrect in spellings. It was more about the instruction given to the LLM that okay, this is how you're supposed to do a task. And if you notice here, these are not like in a single thread. This is basically the single message that I have edited. So it does not even retain that sort of a history that okay, the previous one was incorrect, so I have to correct it now, and I have to use some sort of a different mechanism. So these are all in the same thread, in the same message, and it's just an edited message. So yeah, giving it simple instructions is how it's going to solve the problems. And if um, I have to give you one advice on how to write a carefully written prompt, you have to understand that LLMs are not experts. They're basically very, very dumb, but very eager sort of assistants that we have. So they're eager because they're not going to refuse, they're not going to push back that, okay, I'm not going to do this for you until and unless it's very harmful. And they're not going to delay, they're not going to postpone things, but they don't know which way they have to choose. So okay, let's say you are a computer science student who has studied computer science for 4 years. You are going to have a different sort of thought process than someone who has went to medical school, for example. LLMs, however, are trained on a generic data, so they are. a jack of all trades, they are a master of none. Especially if we're talking about pre-trained models and we're talking about the enterprise models that are available. So what we want to do is give them instructions and give them very, very simple instructions. Break them down. Don't use complex sentences. Use short sentences, and think of it as if you are training your intern or your student. Basically, you are a teacher and your LLM is the student, and then, like, suppose that, and then give it a prompt. And before, like, you even submit your prompt to anything, if it's something important, if it's something crucial, just give your prompt a read once. And are you able to understand what you're saying there? If you were someone who had no context to the entire conversation and you give that sort of a prompt, whichever you are giving, are you able to understand what you want the LLM to do? If you are, that's great. If you're not, then you might want to change the structure, you might want to change the wording, the way the words, the number of words that you have used, the variety of words that you have used. Um, there was another point. Okay, so I think we can go ahead.
Hani bhai, there's a question in the chat for you. Ali Nasir is asking, Hani, can you tell why GPT hallucinate in telling R in strawberry?
Okay, so that's a great question. The thing is, when we're telling it to perform any sort of a task and it relates to reasoning, we want to make absolutely sure that we are providing the right way to complete that task. Because if you're not providing a way of, if you're not providing a set of instructions, maybe let's say counting hours is a very simple instruction. For you it would be, for a human it would be, but for an LLM it has a variety of options to do so. It's going to just, like, maybe count the phonetics, count the semantic similarity between similar sounding words, and then come up with an answer. So it tends to take shortcuts when you are not providing enough instructions. So the key is in the detail, and since you have not provided, in case you have not provided the instructions that, okay, this is how I want you to count the R's in strawberry, it's going to select the best way in which it has to use the least amount of thinking, the least amount of reasoning, the least amount of tokens, essentially. So that's how it was programmed, and that's how most of them are going to work. This specific instruction is not going to work for every LLM. So for Gemini, you might want to have different sort of keywords. You might want to structure it differently, and that's something that you're going to get through with experimenting. Um, so yeah, experiment. Give it like 4 to 5 minutes, and you will come up with a prompt that will solve the problem. When we're talking about prompt engineering, again, it's not about simple tasks like this. It's more about complex tasks. But there are going to be some stupid mistakes made by LLMs like this. How we can overcome hallucination instead of giving vector DB. So instead of giving vector DB, we want the LLM to apologize for not having enough information, and that I do not want, that I am not that I am not able to generate information. Like, I'm not able to generate the content because I do not have information. I'm sorry, something like that. And that's something we can fix in the prompt. So let's say you have a prompt that's maybe 60 lines. At the end of the prompt, you want to give it a small note that if you do not have enough information, You're not allowed to add anything from your own knowledge. The thing is that the information keyword is very relative and contextual here. So if you're like if you have specified above that okay, I'm going to give you text, or I'm going to give you info, or I'm going to give you context or something like that, you are supposed to use the same word below for like the LLM to understand that okay, I do like the user, the text that the user has given, that's what he's talking about. So if you have used information above that, I'm giving you information, I am giving you this information, complete these tasks, and at the end it would be something like, if you do not have enough information, do not generate anything, or you could say, um, do not add anything from your own knowledge. So it's going to be a very simple short prompt, and you might want to experiment with its variations, that okay, with what sort of wording I want to use with this node, but try to use it at the end, because that's where it's going to be very effective. There's a problem with LLMs that is called lost in context or something. Let me Google it out for you guys. So it's called the lost in the middle problem, where if you give it a bunch of instructions, it's not going to obey all of them if it's not a good model. So if you're talking about 4 mini, it's probably going to lose context after, like in, let's say it's a 30 line prompt, maybe the instruction on the 15th line it's going to ignore, because that's how it works. That's how the tokenizers work. The whatever is provided at the very beginning and whatever is provided at the very end, those are the two things that's going to like very cleanly make sure that it follows. So when we're talking about model limitations, I think you guys must know about context window. Then there are things to overcome, such as map reduce and refine. If anyone has any questions regarding prompt engineering, please throw them in the chat, because we're kind of like near the end of the session. Um, Next, there's the problem with Gen AI demos. Any tool that you are going to use for the sake of generative AI, it's going to have a demo and it's not going to be very accurate. We have examples such as Devin, we have examples such as Cursor AI. They they did not exactly lie, but their capabilities were not as great as you would think. So for Cursor, for example, that I have used personally, if the line of code that I want to edit is more than like 20 lines, it's going to mess up. It does not even remember uh, a variable I introduced in the same file, which is used 40 lines below. So it has problems. All of these Gen AI demos are very mythical sort of thing. Um, Lastly, let's talk about the Google offerings for generative AI. As we all know, there's the Google Cloud platform. They have ready-made cloud solutions. They have ready-made AI solutions as well. Then what you might want to do as a student is try to sell something, try to get something on the listing for Google Cloud Marketplace, because that's where people tend to like, they are able to make money from that. So there's the Google Cloud Marketplace solutions. Build your own custom AI solution that only uses prompt engineering, for example, and yep, start making money. Then there's the ready-made AI solutions that are existing on the Google Cloud Marketplace, which from which you can take inspiration. There's the Vertex AI playground, and then there's the AI playground. So when we're talking about the Vertex AI, it's the complete Google machine learning solution. It's the entire portal for machine learning, where you can get started with fine tuning. You can work with You can work with pre-trained models, base models. That's all sort of that machine learning field. When we're talking about the AI playground, it's more towards it's catered more towards a little less technical, towards the non-technical people, where you can just use the prompts to come up with results. Then we have the Gemini 1.5 Flash, which is like it's said to be the competitor of GPT-4o, and it has a free tier and it's a substantial free tier. Like I don't think any student or someone who is working on a personal project is going to need more than the free tier for testing out their app. Unless you start summarizing entire books, then you're probably going to get a problem. Lastly, I wanted to talk about the great uh, aspect of multimodality that Google has to offer, because there are cases where I would go to ChatGPT, give it an image, and ask it to compute some sort of a solution. It might not be able to do so, and like with a number of prompts. But the same thing, I would go over to the Gemini chat interface, and it would be like easily able to do what ChatGPT cannot when we're talking about images. So let's take the question, Umar Hassani. Okay, so when we're talking about the future aspects, Umar, it's mostly generative AI is mostly going to be like at the state that it is today. It's going to be a tool essentially, and the ability to articulate for an engineer is going to be the most important thing from all of that. So if you are given a set of instructions and those are on base of that, you are like engineering a software, that's something generative AI could replace an engineer with. But if you are able to push back, if you are able to drive a client meeting, if you are able to drive a sales meeting into something that is beneficial to a use case, that's not something AI is at this moment is very well trained for. For growth aspects in Pakistan, we do not really have something that we can sell internally. It's usually going to be something that we have to sell to some sort of foreign companies. Um, Ahmed, let me know if we have any other questions. Okay, we have. Attention to detail for the answer of Rafedil's question. Attention to detail is the most important aspect of them all. जेन एआई के ऊपर जितना भी आपने काम किया होगा उसका लाइक इतना फायदा नहीं होगा इफ इट्स जस्ट गोइंग टू कॉपी ट्यूटोरियल्स फ्रॉम द यूट्यूब. तो अटेंशन टू डिटेल यूज के स्पेसिफिक चीजें बनाओ, you'll probably get a job in Gen AI field. Ahmed, can you confirm how much time is left?
So we got like 3 minutes more in the meeting to end.
Oh, okay. So, lastly, I want to stress upon the fact that don't go for certificates, go for certifications. Certifications are where you have to clear some sort of a invigilated exam to earn, because that is something that is going to help you as a student, because that's like a proof that you have completed an entire course instead of a Udemy or a simple course completion certificate. um, Try to create impact when we're talking about um, when we're talking about developing any Gen AI solutions. Be use case specific instead of copying direct demos from online, because there are a lot of applications. This is like a clearly new field, and we have a lot of applications. So be use case specific, search on the web, ask ChatGPT if it is use case specific, whatever I am working on, and you're going to do great. When we're talking about the impact on jobs, Gen AI is going to be just a tool. It's probably in the end going to be something like a database that we configure whenever some sort of a non-trivial problem comes in. We're going to end up using Gen AI API for completing that task. For a software engineer or someone who's learning, it's going to be something like a calculator for children. As a child, you don't want to use a calculator a lot, but when you're talking about when we grow up and we start understanding how basic math works, that's a point where we can end up like using a scientific calculator. Gen AI is going to be something very similar as well. So polish your basics, and then start using Gen AI afterwards.
So, thank you so much, Hani bhai. The meeting is about to end, and thank you so much for a wonderful session. I want to thank everyone for joining in the session, and apology for those who couldn't get their questions answered, especially the last one only. So, we will have your questions answered by the host himself if you can send this message to me on in the channel chat in machine learning community, and we hope to see you soon